Welcome to Beyond the Forecast. We're going to have a good time today. Brian Michigan back with me. We're going to be talking a lot about microclimates, astronomy, cool stuff happening in Mexico actually too, so weather related. So a lot of fun stuff we're going to talk about today.
Yeah, a lot of cool stuff. Seasonality even as well, just the change of the seasons. We're kind of in it now with spring, but kind of talking about the difference between, the peak of the summer versus the peak of the winter and how, drastic the change can be from one extreme to the next.
Yes, and that always depends on where you live on Earth. It could be here, you could be in Siberia, you could be in a tropical island. Each zone has its own climate.
And most importantly, your proximity to water.
Yes.
Because water, we call it the great moderator for a reason. We'll break that down in a little bit. But the closer you are to water, kind of the less extreme things can be from season to season. And that's especially true summer to winter. Even in the United States, you can see huge differences if you go, maybe just over the Appalachians into the Midwest compared to here in coastal Virginia and North Carolina. We'll break it all down. You can classify Virginia and really most of North Carolina as this humid subtropical climate. So the reason it's subtropical is we're still prone to frosts and freezes. We even get snow. We got snow this past winter.
It was awesome.
Yeah, Jeff loved it. Jeff, Minnesota
the
guy.
snow was awesome, by the way. The snow was awesome. All right, back to you.
Yeah. So we're still, subject to the frosts, to the freezes. You got to go really south into, southern Florida until we're really kind of classified as a tropical climate. So that doesn't make its way very far north. Really, a lot of the East Coast, especially the Southeast, is subtropical. Now, you can kind of break it down, a little bit further. We have the Piedmont and we have the Tidewater. The Tidewater region is heavily, heavily influenced our weather day to day, season to season, by the water and specifically the water temperature. Now, the water, it has a high specific heat capacity. That means that it takes a lot of energy to change the temperature of the water compared to the temperature of land or air. So essentially think radiation, the sun's radiation heats the ground heats the air. It takes a little bit longer. Just think the water temperatures.
A lot longer.
Yeah, a lot longer.
Yeah.
Just think in March, the water temperatures can be in the 40s, just off the coast in the Atlantic. In the summer, it could be right around 80 degrees. But that transition takes so long. It takes so much energy to get that going. Now, with water's ability to kind of retain heat, it stays warmer. So you can get, cold snaps in October, November.
Yep.
But the water temperatures are still kind of mild. They're not too cold
Not
just
super cold
yet.
Yep.
It takes a while. So it's able to, retain some of that heat. And as a result, in certain times of the year, you'll get different temperatures, whether you're along the coastline or well inland. That they're kind of influenced by the water here. So if we kind of look, water, everybody says, at least in meteorology, I've heard the phrase from tons of professors, the water is the great moderator. Now, the Tidewater region has a slightly less extreme temperature swing in the summer and winter compared to maybe Farmville. I put Farmville up here, for example, in the Piedmont region, you could say. Now, look, it's not super extreme here in this example. You could see July, your average high temperature in Norfolk is going to be, in those upper 80s. In Farmville, it's right around 90. It's just a couple of degrees difference. In January in Norfolk, around 48. Farmville, 47 for January's high temperatures. So again, it's not super extreme, but you can see that the further you are away from the water in a hyper-local scenario here, the closer you are to the water, the less fluctuations you're going to see. This is kind of a more small scale because we're not too far from Farmville, but
have you ever been to Farmville, by the way?
I've never been. No.
I highly recommend it, especially if you want to travel to the west. Instead of taking the Route 64 and going through Richmond, it's fast, it's easy, but it's not very scenic because it's trees surrounding the freeway the whole time.
Yeah.
If you take Route 460 that goes through Farmville, it's a wonderful drive. Takes a little bit longer, but if you're going to a destination that brings you not to Charlottesville but farther south, then it's worth your time to travel that way. It's nice.
Got to do some exploring. Virginia, the interior sections.
It's a lot to see.
I've driven, surf trips to Florida or to the Outer Banks. I've kind of just driven through my whole life, but never really stopped. I have friends who went to school at Shenandoah, and they love Shenandoah Valley. They love the Blue Ridge Mountains. They love it up there. And I think they can even, they can kind of attest to the changes in the weather just from a short distance. Because I remember when I got this job, they were talking to me, oh, Virginia Beach, like this area, the Hampton Roads area is awesome.
Yeah.
It's a little bit more humid, they say. It's because we have so much water around and a lot of kind of, I guess you can almost say swampy areas, a lot of still water, which actually in certain conditions, we can actually get a little bit more fog throughout the year.
Yes.
In some of these, little microclimates, all these little swamps that we have, especially along the eastern shore, that throughout the year with all kind of this moisture around, we can be a little bit more humid. That whenever it does heat up in the summer, it could feel a little bit hotter here compared to maybe somewhere inland. Like I'm going to guess where you grew up in Minnesota.
Yep.
When it got hot, sure, you had humid days, but I'm sure there wasn't anything as crazy to kind of the humidity that you maybe feel in Hampton Roads or even, North Carolina going down to South Carolina where the humidity can just be a huge factor.
Higher sometimes.
Yes.
Well, higher in Minnesota and Iowa than it can be there. Transpiration from the crops.
From the crops.
That's your source for the humidity in the summer. So
a little bit different here.
It's a totally different reason why it's humid. But if you have a whole field full of corn and those thick green leaves.
Corn sweat. Is that what they call it?
Yes,
corn sweat?
Transpiration. So it sucks the water up out of the soil. It transpires out the leaves. Mm-hmm. So you can get dew points, the absolute measure of moisture in the air. You can get dew points in the 80s in Iowa.
Which is crazy.
It's stifling.
A little bit harder to do that, say, go for a little further west, Montana, into the mountains.
Right.
Way drier.
Get that. Yeah.
Or the desert southwest. If it could be 80, 90, 100 degrees, but your dew points could be super low, so it's not as humid. So it's more of a dry heat. Maybe feels a little bit more comfortable. I know 100 degrees sounds crazy, but it could be a little bit more comfortable at 100 degrees in the desert southwest than if it were 85 degrees in Hampton Roads, but the dew points are in the 70s in the summer.
And it feels better because of how our bodies work. When we sweat, the sweat evaporates. When water or liquid evaporates, the temperature drops and cools. So if you can evaporate your sweat, then you're cooling yourself down. If it's too humid and you can't evaporate your sweat, you're not cooling down. So you continue to be hot, and then now you're coated in a layer of water and a little bit of salt too and stuff like that.
So I wanted to pull this up. Minneapolis, Minnesota, average January temperature, high temperature, 24 degrees.
Balmy.
Balmy. In July, 83. That's a 59, almost 60 degree difference season to season. Here in Hampton Roads, that difference between the summer, the middle of the summer, and in the winter is a way less. It's probably half that temperature difference, almost half. So
that was cold.
Yeah, and that's all because of the ocean. That's all because of the Chesapeake. We live almost surrounded by water. We have so many rivers. We have water everywhere. And it actually, the closer you are to water, you kind of get a little bit more rainfall throughout the year as well. Mm-hmm. And this is actually a little bit of a more extreme example, Norfolk and Farmville. Norfolk averages annually around 50 inches of rain per year.
Yep.
Farmville, it's around 10 inches less. And that's the more extreme kind of stat that I found. The temperature difference might not be, that much different from, the Piedmont region to the Tidewater region, but the rainfall is a much bigger stat that I think is pretty interesting. I think most likely sea breeze fronts during the summer, sea breeze pop-up storms that we get in the summertime.
I have two hypotheses on this, and I want to look at the month-by-month data maybe after this. It could be that, or it could be tropical systems.
Could also be tropical systems.
Because we get that late season boost in the rainfall amount here in Hampton Roads because of tropical systems. Remember, it's not a hurricane directly hitting us, it's a hurricane or storm hitting Florida, Alabama, whatever, down towards the Gulf, and the leftovers come our direction. We get a little bit more moisture and rainfall from that too.
Yeah, and it's not to say that, interior sections of Virginia or even the Blue Ridge Mountains or the Appalachians can't get this tropical moisture, because we saw with Helene where, some places in North Carolina were devastated by the flooding. But the closer you are to the water, I guess the better chance you have of being just influenced by sea breeze storms, tropical systems, things of that nature. The closer you are to water, you're going to potentially see more rainfall throughout the year. but you're also going to see, moderated temperatures a bit throughout the year as well. And that's all because of the specific heat capacity. So that the water molecules essentially have a much more efficient way of retaining its heat.
We're going to have to do maybe a future video on why you can live near the ocean like in California and you don't get rainfall. Because it's opposite. It's totally different.
A little bit opposite.
But we got to keep moving on here because we have more topics to hit. So stay tuned because there's more to come. All right, welcome back to Beyond the Forecast. We're going to do a quick astronomy update, but actually I do want to add some other things too before we get into that, because we didn't talk about that dust storm that went through northern Mexico, and that was the next thing.
This is so cool.
Yeah, that's the next thing I had queued up. So let's put this on. Let's just go full screen with this. Look at this thing.
It's the loop of the day.
Yep, it's the loop of the day. This is from a couple of days ago. This is from the GOES West satellite. So shout out to NOAA and the other agencies for sharing this. You can see the dust storms. So dust storms are created by fronts. They're created by thunderstorms or outflow boundaries, areas of cooler air, and this one just continued to progress. We're looking at northern Mexico, and this dust storm is moving to the south. You can see the border right there. Look at that.
Unreal. And look at how kind of on the left side of your screen as it's continuing to go down, it looks like it maybe is getting caught up in some elevation. Maybe look at how ready, almost right there on the left side. It kind of can't make it over the mountains there. It looks like it's getting influenced by elevation, but still, really cool shot.
Yeah, you can see it really when the sun is getting ready to set because the shadows of the mountains are being cast.
Yes.
Because that's why it gets darker at the end. This is just so cool.
So cool. I mean, and they, GOES has, their loop of the day. It wouldn't surprise me if, maybe today's or even yesterday's or, maybe in a couple days that wildfires in New Jersey could be one. It's GOES loop of the day is always worth checking out if you're trying to nerd out on some, the latest weather phenomenon that's happening around the country.
Yeah, and there can be some really strange stuff too that the captures where you can see, let's say in Hawaii, for example, the high elevation can create a wake of clouds around them. It's just, there's so many different things that you can see in the loop of the day. Thunderstorms developing is cool. Dust storms where you have clear conditions though. This is absolutely phenomenal. So cool stuff. Wanted to share that with you, but let's move on to the astronomy update, the actual topics of today.
I'm so excited for this one. I'm so excited. I have so many questions.
So we'll bring this full so everyone can see what's going on. This is an illustration. This is not a image from a scientific mission.
How cool would that be if it was?
Yeah, well, we'd have to figure out how to fly a spacecraft at light speed.
It'd be a little hard to do that.
This is 120 light years away from Earth. So we're looking at the K2-18 star system. I want to show you this image here. This is that the no? It's actually the third one. So I'm not going to get ahead of myself. I'll show you what the star looks like from Earth in a little bit. But we're looking at a planetary system where there's two planets. You can see the distant one that's brown in the middle of the screen. The blue one is the one that we're talking about. It's believed to maybe have life.
And it's crazy that maybe if you kind of explain how they're even able to make these discoveries. Me and Jeff were talking about this yesterday, and I had like 3 different questions that I asked him in a span of 30 seconds about like how in the world are they even able to say this has a possibility to harbor life if it's so far away, we can't see it. We're essentially just figuring out the atmospheric composition, as you can see by this graphic, through different ways, wavelengths of light.
Yes, so when we look at another solar system, so our solar system, we're not all on the exact same plane, but we're pretty close. Plane as in, and let me kind of explain this with my hand. So plane as in, if, I'm just going to grab this. If this is the sun, this SD card is the sun, and let me grab another SD card, or this thing, and we're the Earth, so we're on the same plane.
Yes.
We're not like this, we're not like this. So in this star system, we're essentially looking again at the same plane. So this planet is passing in front of its star. The star gets a little bit dimmer. As that dimming happens, we can analyze what we're seeing from that dimming of light. It's absolutely fascinating.
And depending on the wavelengths of light, we can figure out the composition potentially of the atmosphere of the body that's passing in front of that star.
Yeah, so let's go back to this graphic. There's a lot to go on here. I just want to show you, this is all from the James Webb Space Telescope. This is from the instrument called the Near Infrared Imager and Stitless Spectrograph.
That's a fancy word there.
Slitless spectrograph.
Huh.
Ugh.
Yeah, that's
a tongue twister.
Yeah, that is a tongue twister.
I didn't develop this instrument, so I apologize to the one that did because I butchered it the first time. But it's also from another instrument too, the near-infrared spectrograph as well. So we're looking at the displaying of the abundance of methane and carbon dioxide in the exoplanet's atmosphere, basically the planet that we're looking at, the blue one that we see in the background of this image right here, as also the possible detection of a molecule called dimethyl sulfide, or DMS for short.
Huh.
So there could be a presence of an ocean underneath a hydrogen-rich atmosphere on K2-18b. K2-18a, by the way, is the other planet. That's not one that we're not interested in. K2-18b, this planet, let's go back to the full image. Right there, the blue one, is estimated to be 8.6 times as massive as Earth. It orbits the cool red dwarf star, K2-18, in a habitable zone, and it lies around 110 to 120 light years from Earth. So we couldn't get there fast.
No.
But 120 light years in the grand scheme of things is not that far away.
Right.
So 120 years ago is the year 1905. So we didn't have television broadcasts back then, but let's say you could instantly teleport to the planet right now. And you had a big, powerful telescope where you could zoom all the way in on New York City. You would be looking at people walking around in 1905.
In the past.
Yes.
Yeah. It's crazy how, like, you look out into the night sky. All that light that you see is coming from millions and millions of years away. In some cases, you could be looking millions and millions of years in the past.
Yes.
In some distant place out there, if they had a big enough telescope and zoomed it in on Earth, they could see the dinosaurs walking around.
Yes, you could.
That's crazy.
Exactly.
That's so crazy.
And it's just because of the distance the light has to travel.
Yeah.
So our radio signal technology and our television signal technology, that has transmitted from Earth, but it's only so far away.
Right.
Since basically the amount of light years it is away from Earth is the years that it started.
Right.
So you go far enough away from Earth and you're looking at Earth in the past, which is
so mind-boggling, right? And the thing is, our technology now, obviously, it's a lot different than 100 years ago, 200 years ago. But in the grand scheme of things, it's only been quite recent that we've been able to develop this technology to have our radio waves going out into the vastness of space. So who knows? Like, if there's life out there, very slim chance that they've even picked up on our radio signals or any signs of us yet.
Right. Because we don't exist.
Yeah.
In terms of that technology.
In terms of that technology. And again, back to the kind of the dinosaur example, if there's a place way out there that's, they wouldn't even have any clue. If they were looking and seeing the dinosaurs, they'd be like, oh, look at that. There's a planet with species. But they wouldn't see us yet. That's for sure.
So you have to remember when we watch sci-fi movies, maybe like an Interstellar or other type of movies, those movies have a different sort of communication method.
Right.
So if you're traveling at warp speed from point A to get back to Earth, point A to point B, you're going to travel faster than your radio signal that you sent out. So you're going to beat your own message.
Yes.
So you have to say, okay, they have a different way to teleport their signal, their message. So that's fine. But it's absolutely amazing how we can look in the past and how with the James Webb Space Telescope we can start to maybe identify what we're seeing from these exoplanets. We have no way to get there in a human lifetime because even if you could travel at light speed, you're still too slow.
Wait,
120 years.
Yeah, 120 years. And unless we figure out a way to lengthen our lifespan even more than 120 years, likely not getting there.
You can see the star from Earth with a good telescope in a dark sky. Now, this is a long exposure. Thanks to Jeff Goldstein for this image. This is the image of the star and the planetary system. We can only see the star, the K2-18, but it's that arrow pointing right at that star right there. So that's a cool dwarf star, which the sun will become one day.
Right. Millions of years, right?
Yeah, a long time from now.
I also, when reading the stats of the planet, it was interesting. 33 days for an orbit.
Yes.
It's close.
What's our orbit? 365.25 days.
Something, yeah, around there.
Yep. So we're looking at an orbit that's 33 days. So that shows you how cool the star is.
Right.
Because you can't be, if you're in a 33-day orbit around the sun,
yeah.
I mean, that's closer than Mercury
yeah.
by a third,
yeah.
basically. So you're smoking.
Smoking hot. And I think it's going to be interesting because obviously all stars are, you know, prone to, you know, they throw out solar radiation into space. With that, you know, distance being so close to that star, 33-day orbit, that's really close. It'd be interesting if that planet, you know, how it copes with kind of the radiation because it's so close.
Yeah, a strong magnetic field could protect you.
Right.
But at the same time, if you're on Io, the moon that orbits Jupiter.
Yes.
Or if you're on, any of the really moons essentially, but those radiation belts are so close and so intense, you'd just be spacecraft get destroyed if they're in it too long. So they make quick passes through Jupiter's magnetic fields to get closer to the moon. So Europa Clipper mission, that spacecraft again is going to dive in close to Europa, and then it's going to go way away to get away from that intense radiation. So the radiation thing, you can't really study that remotely.
Yeah.
So
way tougher.
Maybe we'll see if we can get a mission to go there in a couple weeks. We'll get some figured out. We're going to take another quick break. We have a couple more things we're going to talk about on Beyond the Forecast. Stay tuned. All right, welcome back. We have a quick update on what we're going to be working on here as we go into the next couple of weeks. We're going to be looking at the hurricane season here coming up in the weeks ahead. We have the anniversary for the Virginia Beach tornado that we're going to have more on in the coming weeks too. I'm going to be talking to the Virginia Spaceport Authority. They have some cool programs that are coming up in the months ahead, and with going back to the hurricanes thing that we're going to be doing, we're all going to be doing different things on the weather team.
Yeah, at least for me, I'll be focusing more on the storm surge, beach erosion side of things, which, for those who don't know, the type of erosion that we consistently deal with annually, really day to day in this area, is beach erosion. Our beaches are constantly changing. They're constantly being broken down and built back up in different areas. We have dredging going on at Virginia Beach as we speak. And that's essential because over the course of the winter, the beaches have been battered. And so we need to replenish those, not just to fit more people on the beach for the summer, but also to protect our coastline and protect our dune systems out there. So that's kind of what I've been working on. It's been fun to kind of go, tour around. Actually, earlier today, I got to go around and check out some of the local beaches and some of the dune systems, which there are signs that they've been battered over the course of this past winter. And this past winter, I know I've been complaining as a surfer. A lot of people have been complaining as surfers that it's been a little bit of a small, kind of a lackluster winter in terms of waves. It's still, during the winter, still more than the summer, more waves in the summer. And, that constant beating up of the coastline, it takes a toll over time. And it was crazy to see that today with some of the dune systems that are pretty battered.
Yeah, the dunes are battered. There's something that can't be destroyed, and they're very hard to rebuild. And to kind of build back up. So we're going to be looking forward to that. I'm going to be talking about the hurricane season forecast and some of the difficulties with that. We're going to have fun with that. We'll let you know when that's going to happen here, but that's coming soon. So a lot of things happening here in the weather department, and a lot of things happening, of course, beyond the forecast. Enjoy the rest of your day. We'll see you next time.